Good evening. My presentation is about zero error in Vernier calipers. Before start using any Vernier caliper, you should verify that you are using a caliper which is free of zero error. How to make a checking for the zero error of a Vernier caliper? First of all, we should close the Vernier caliper completely and we should apply a value of force, and this value of force for closing the caliper is the same as the force when you are using the caliper for measurement process. After closing the caliper and locking the screw, you should check for the reading of the caliper. Your caliper should read 0, which means that the 0 line on the main scale should align with the 0 line on the Vernier scale, same like what we have in below photo. If there is an offset between the two zeros, then we have either a positive or negative zero error. Let's understand what's the meaning of a positive zero error. In this photo we have a caliper which is totally closed, and this caliper should read 0, but as you see there is an offset between the 0 line on the main scale and the 0 line on the Vernier scale. So these two lines are not aligning with each other, so there is an offset, which means that there is a reading for this caliper even it is totally closed. So in case that the 0 line of the Vernier caliper lies right to the 0 line of the main scale, in this case we have a positive zero error. And positive zero error means if we are using this caliper with the existence of this error, or all our reading will be more than the correct value. So this is a positive zero value. What about the magnitude or the value of this error? Actually, we read this caliper regularly, as we have said. So we should search for one line on the Vernier scale, which lines up with one line on the main scale. So as you see here, the third line on the Vernier scale lines up with one line on the main scale. So the reading for the amount of error is plus 0.3 of millimeter. So in this case, we have a positive zero error, and the value of this error is 0.3 of a millimeter. Let's understand the opposite case. In this case, as you see, the Vernier caliper is completely closed, but the zero line of the Vernier scale lies left to the zero line of the main scale. So in this case, we have a negative zero error. And negative zero error means if we are using this caliper with the existence of this error, all our reading will be less than the correct value. So in this case, we have a negative zero error. What about computing the value or the magnitude of this error? In this case, as you see here, we have an offset, and the zero line of the Vernier lies to the left of the zero of the main scale, so we have negative zero error. How to compute for the value of this error? We move in a reverse manner in order to read the value of this error. So we consider the last line on the Vernier scale to be the first line, which means that this line will become line number 0, and this line will become line number 1, and this line will be line number 2, etc. So in order to compute for the value of the zero error, as you see here, the fifth line on the Vernier scale lines up with one line on the main scale. So the value of the zero error is a negative 0.5 mm. So this is the meaning of the negative zero error. Let's have another example for a positive zero error in case of metric system and a British system. As you see here, we have a Vernier caliper with mixed systems. The system below is a metric system with 0.05 mm precision, and in the top we have a British or inch system with a precision of 1/128. As you see here, the Vernier caliper is completely closed, and even it is closed, there is an offset between the zero line on the main scale and the zero line on the Vernier scale. Let's start with the metric system. So, as we have the zero Vernier lines is right to the zero line on the main scale, so we have a positive zero error. So in order to compute for the value of this error, we read the Vernier scale regularly from left to right. So in this case, as you see, this line on the Vernier scale lines up with one line on the main scale. So this line, as we have mentioned before, is read as plus 0.60 mm. So in this case, we say that we have a positive zero error, and the value of this zero error is 0.60 mm. Let's understand the zero error in the inch system in the above. The same as you see, there is an offset between the two zeros. So we read the Vernier scale regularly, means we read it from left to right. So the third line on the Vernier scale lines up with one line on the main scale. So the reading of this line, as we have said in a previous presentation, is plus 3/128 of an inch. So if you are using this caliper with the existence of this zero error and you are using the metric system, once you finished your reading, you should subtract the value of the zero error in order to make the correction. Let's understand with the same caliper for the negative zero error. As you see here, for both metric and British system, the zero line on the Vernier scales lie up to the left of the zero line on the main scales. So in this case, we have a negative zero error. So in case of negative zero error, in order to read the Vernier scale, we should move reversely, which means we should move from right to left in order to read the Vernier scale. So let's start with the metric system. So because we have a negative zero error, so we should move in this way. So as you see here, this line on the Vernier scale lines up with one line on the main scale. But how to read this value of this line or this error? We should read it in this way. So this is the value of the zero error, which means that the last line, we consider it to be line number 0. This line will be line number 1, which is 0.10 mm, and this line will be line 0.20 mm. So in this case, the value of the zero error is simply minus 0.20 mm. Let's understand how to compute for the negative zero error in the case of inch system in the above. As you see here, line number 7 on the Vernier scale lines up with one line on the main scale. So as we have a negative 0 error, so in order to read the Vernier scale, we should move in this direction. So we consider this line to be the first line on the Vernier scale, which means that the reading of this line is -1 over 128 of an inch. So if you are using the metric system for this caliper, you should add the 0.20 mm for your reading in order to make your correct reading. And in case of an inch, you should add 1 over 128 of an inch. Let's treat with these examples here. Find the 0 error of the Vernier calipers below. Regarding the scale in the above, it is the main scale, which means this scale is the main scale. And regarding the scale here below, this is the Vernier scale. So as you see here, the 0 line of the Vernier scale comes right to the 0 line of the main scale. So in this case, we have a positive 0 error. So this is the dimension of this error. It is positive. But what about the value of this error? We read the Vernier regularly. We search for one line on the Vernier scale, which lines up with one line on the main scale. So the line number 6 lines up with one line on the main scale. So the reading of this line is simply 0.6 mm. So we say for this case of a Vernier caliper that the 0 error is plus 0.6 mm. Let's see this another example here. As the 0 line of the Vernier scale comes left to the 0 line of the main scale, so in this case we have a negative 0 error. So in order to read the Vernier scale, we should read it in this direction. Now we search for the alignment. As you see here, this line on the Vernier scale lines up with this line. And the value of the reading is this value. So this line is considered as the line number 6 on the Vernier scale. So the 0 error is minus 0.6 mm. Let's see this example. The same here. This is the 0 line of the Vernier scale. It is left to the 0 line of the main scale, so we have a negative 0 error. So we should move in this direction. As you see here, this line lines up with this line. So we should read it in this way. So this is considered as line number 4. So the value of the 0 error is minus 0.4 mm. In this example here, we have a positive 0 error. So we read the Vernier scale regularly in this direction. And as you see here, the line number 3 lines up with this line on the main scale. So the reading of the Vernier scale is 0.03 mm. So this is the way how to determine the direction of the 0 error and how to determine the value or the magnitude of this error. Find the 0 error and the correct reading of the Vernier calipers below. In this case, we are using a caliper and there is already a 0 error in this caliper. So first we should determine the value of the 0 error, and after using this caliper, we should make the correction in order to get the correct reading. So in the top here, we have the Vernier caliper, or the caliper which is totally closed. So we can simply now determine how much the zero error. So as you see here, the zero line on the Vernier scale comes left to the zero line of the main scale. So we have a negative zero error. So in order to read the Vernier scale, we move in this direction. So as you see here, this line on the Vernier scale lines up with this line. So this line is considered as line number 3. So it is minus 0.3 mm. So this is the zero error. It is negative zero error, and the value is 0.3 mm. And below here we are using this caliper. Even we have a negative zero error, and we get this value of reading. So the reading of this caliper is simply, as you see here, this is the zero line of the Vernier scale. So we don't have any value of complete millimeter. As you see here, the line number 6 on the Vernier scale lines up with this line. So the value of the reading here is 0.6 mm. So this is the reading of this caliper. Now we should make a correction for the reading. So how to correct the reading? We say what is the observed reading. So we have 0.6 mm, and we should subtract the zero error from this value. So minus 0.3, which means that we should add 0.3 in this case, and the total, or the correct reading, is simply 0.9 mm. So this is the correction, or the correct value. So as you see here, this is the value of the zero error. It is minus 0.3 mm, and this is the correct reading. It is 0.9 mm. Let's have another example here. In this case, in the top, the caliper is totally closed, so we have a positive zero error. So the direction of the error is positive. So how much the value of this error? So as you see here, line number 3 lines up with this line on the main scale. So the value of the zero error is plus 0.3 mm. And below, this is the reading of the caliper, or the observed reading. So the reading of this caliper, this is the reference line in order to read the main scale. So the zero line on the Vernier scale comes right to this line, and this line is line number 10. So the reading here is 10 points. As you see here, line number 6 lines up with this line. So it's 10.6 mm. So this is called the observed reading. So what's the correct reading? As we have a positive zero error, so the correct reading is simply the observed reading, which is 10.6 minus 0.3 mm, and simply it is 10.3 mm. So this is the correct value for this caliper. So this is the value of the zero error. It is plus 0.3 mm. This is the observed reading. It is 10.6. And regarding the correct reading, this is the correct reading. It is 10.3 mm. Let's have this last example here. Here we have a negative zero error. So we read the Vernier scale in this direction. As you see here, this line on the Vernier scale lines up with this line. So this line is considered to be the line number 6. So it is minus 0.6 mm. Here we are using the caliper, and this is the observed reading. This is the 0 line of the Vernier scale. So we should read this line on the main scale. And this line is simply line 64. So 64 point. Line number 3 on the Vernier scale lines up with this line. So it's 64.3 mm. So this is the value of the zero error, and this is the reading of the observed reading. And regarding the correct reading, it is simply 64.3 plus 0.6, which is 64.9 mm. So this is the way how to compute for the zero error and how to make the correction for any reading. That's all about zero error. Thanks a lot for your watching. Goodbye.